the 25P over to the other side, the 250,000P, it might make more sense this way. Plus Q is equal to 50,000 because it'll come out looking more like what we expect it to. And then subtract Q from both sides. So when we do that, then we have 25,000 times P is equal to 50,000 minus Q. Then we divide both sides by the 25,000. But what you need to remember from there is that once you divide that 25,000 off, it's over both of these, so you have to be careful and actually divide both terms. So 50,000 over 25,000 minus Q over 25,000. Now you can leave it written this way, but we're going to have a harder time taking the derivative of it that way, okay? Because we don't really have a derivative rule that directly operates on that. So that's why I've changed it actually to this. Now, if all we're going to do is plug in, then we could use either flavor of this. But because we're trying to take derivatives, then we really would prefer to have it in this format. So we're going to find the value of Q here. And remember, this is equivalent to what we looked at before. We're going to find the value of Q by plugging into that function. So Q is going to be 50,000 minus 25,000 times the price is 160. And then that gives us 50,000 minus 250 times 1.60 is actually 40,000, I think. Y'all check my math. So the quantity is 10,000. So these two equations are really the same equation, the same relationship, but one of them is solved for Q, and this was the original function that we had solved for P that we did with example 7. Yeah, it's the exact same as what we had in example 7. So that's where this actually came from. Okay? So Q is 10,000, and that's exactly the same result when we did the other problem. So the quantity is 10,000 units. So this is demand, not revenue. Start to write revenue. The demand is 10,000 units, whatever it is, stereos, computer programs, whatever. So now we're going to move on to marginal profit. But before I move on, see if I have any questions about this one. Because the fact that you change places when the independent and dependent variables shouldn't make any difference as to what the paired values are. You're just looking at it in a different order. Okay? And Yeah, that's the same thing I just wrote. So let's look at example 9. And this is the same one that's in the book. So we're talking now about a cost function, and again, this is the same cost function that we had in example 7. The cost function C of Q is given as C of Q equals 2100, there's your fixed cost, plus 0.25Q, which is your marginal cost. And Q has to be between 0 and 50,000, because remember last time when we graphed the problem, basically you have a parabola and its x-intercept, its second x-intercept is at $50,000, so there's no point in looking past for 50,000 units. So what we want to find is marginal profit. Okay, now this is the cost. That is not profit. How do we find profit? We need an equation for profit. Okay, so profit from Q units is equal to the revenue from Q units minus the cost of Q units. And our revenue equation, if you want to look back through your notes, looks like this. Okay? Because we took the price of Q units and multiplied it by the price again, or by the number of units, which was Q, and that's why everything turned out to be Q squared. And then from that we subtract the cost, which is this. I'm recording. Let me pause here for 1 second so I can tell you why you're still here, because I know you got to go. I looked at the amount of material we have left. I don't think it's fair, even though I hate making you wait over fall break to take a test. I don't think it's fair to make you take a test before you go, because you're not ready. I know you're not ready. So our test over chapter 12 will be the Thursday after fall break. Okay? And I've moved all the due dates accordingly. Okay? So our cost, which is given here in this part of the function, is 2100 plus 0.25Q. That means our profit for Q units is, we're going to have to simplify this algebraically because that's going to be a mess if we don't. But it's not hard to simplify, because what we need to do is remember that we're taking the opposite of both of these. So that's going to be 2Q minus 1 over 25,000 Q squared minus 2100 minus 0.25 Q. And when we put these two together, this is going to be a quadratic equation, and normally we want to see the quadratic equation with the quadratic term first. So I'm going to put this down here first. 1 over 25,000 Q squared. And out here at the end, I'm going to put the minus 2100. And then 2 minus 0.25 is 1.75. So the profit for selling Q units is 1 over 25,000 times Q squared plus 1.75 times Q minus $2,100. Now, if you want to know the marginal profit, because that's what it says we want the marginal profit. Marginal means rate of change. Which also means slope. And both of those mean derivative. You gotta get those all tied up because those are all the same thing. So that means we're looking for P prime of Q. Okay? We're needing the derivative of Q. So 2 times 1 over 25,000 is going to be 2 over 25,000. Q, and then 2 minus 1 is going to be just 1. Plus, this is Q to the first, 1 times 1.75 is 1.75. And this is going to be Q to the 1 minus 1, which makes it Q to the 0, and it disappears. And the derivative of the 2100 is a 0. So here is our derivative for profit, which means this is our marginal profit. And since it's marginal, that's dollars profit per unit made and sold.
Can you read again how it's doing?
Excuse me? Say again?
Can you repeat again how it's doing?
Because you bring your 2 down in front.
Okay.
And when you multiply 2 times 1 over 25,000, it's going to be 2 over 25,000.
So the revenue equation, like, is it always 1 over 25,000? Or is that just you get that from the problem?
You get that from the problem
Is it-
itself.
Is it the 0.25 Q? How do you get 25,000?
The 25,000 came from example 7. Do we need to look back at example 7?
Oh, this is still part of that.
This is still where example 7, 8, and 9 are all related.
Oh, okay.
Okay, we're using the same functions over and over again. So if you look in your notes, look right above that, and you'll see the function that we came up with for revenue. It's not that it's always this, but for example 7, it was this.
Okay.
Okay?
Yeah.
So one thing to remember here, tie up these words. This is the calculus part of it. Tie these words together. Remember, you're taking the derivative anytime it says marginal anything. And when you take the derivative is a rate of change, so it's always going to be units of the output, in this case profit, which is dollars, per unit of input. In this case, the input is quantity. Okay? So marginal always has an interpretation as a rate of change. So be careful of that. Now, if you use this equation, which is what we want to do, and it says find the marginal profit from 15,000 units.
According to the book, it's
Mhm.
still not broken down far enough, because I did the equation, it's 2.95, if you stop there, you have to keep breaking it down to get to that 55 cents per unit.
Ah, I missed this. No way. Yeah, I lost a sign somewhere. Hang on. I lost it right here. So you are right. You don't have to turn it around though, because at this point, it's still the same thing. I just dropped the sign, so thank you for catching that. That would have been very important. And I would have caught it in a minute when I got an answer that I know is not right. It would have made no sense. But I'm glad we caught it before then.
So how is it?
How is it?
Yeah, negative, okay.
Yeah, there was a negative, because this was negative. So this was negative, and this is negative. Okay? Now, are we all good? Okay, any other questions?
Do we get to keep our exams?
Excuse me?
Do we get to keep our exams?
Yeah. I don't see any reason why not.
No, is the retake going to be very similar to it?
Very similar. Very similar. And incidentally, through tomorrow, I think, you'll be able to see the actual key to the exam, so you can look and see where you went wrong. But I'll be glad to go over it with anybody. I'll take time one-on-one and go over it with you. Okay? Okay. Gentlemen.
We're talking about.
Okay? So this is your marginal profit, and it wants to know the marginal profit at 15,000. That means we need to plug 15,000 in for Q. So that's gonna be -2 over 25,000. And I think actually in the book, they changed this to 1 over 12,500. But you don't have to reduce the fraction, that's fine, it's fine the way it is. Times Q, and Q is 15,000. Plus 1.75. And before we tack on this part, we'll go ahead and do the arithmetic. And be very careful that you do the arithmetic in the right order here. Be careful how you enter it. So be sure you put your fraction in parentheses so it does that first. And then finally add your 1.75. Did I leave out a sign? Oh, I was like, wow, it's not supposed to be like that. Thank you. I'm going to have to start using the keyboard up here instead of using the mouse because it picks up extra keys. Go back over there. No, that's still not right.
It's one.
I think,
I did the parentheses for the fraction, then I times it by 15,000, and then I just added in points. That's what I did.
do you see what I did?
Yeah,
Yeah, you actually did 150,000.
Yeah. Let's try this again. -2 divided by 25, 1, 2, 3. Close parentheses, open,
Did it again.
yeah. One more is 0. And parentheses. Then we can do plus. I left out my plus.
I'm supposed to do times.
Yeah.
Yeah.
Times the 15,000 plus the.
And that should be 55. Now we need to think about what that 0.55 means. So that is, since this is dollars, how much is that really? That's 55 cents. And watch the wording carefully on this. At 15,000 units, the profit is increasing. This is not past tense, it's present tense because it's continuing to increase at that point. It is increasing 55 cents, although it would be perfectly fine still to use that notation, per additional unit. Okay? So it's increasing 55 cents per additional unit.
So on the test, you're just gonna give it, what, like, a couple problems and then we find the cost revenue and price for all of them?
Yeah,
Okay.
okay?
So we just gotta learn those three things and then we should be.
You need to learn your derivative rules, but you also at the same time need to be learning what marginal means, which means you're taking derivatives, which is why you need the derivative rules. And then you also need to remember the relationship between profit, revenue, and cost. And maybe one of the things I can do to help you is kind of make you a sheet with the main ideas of, you know, if you've got this information, how do you find the revenue function? If you've got this information, how do you find the cost function? If you've got this information, how do you find the profit function? Okay?
Yeah.
Because you're trying to learn concepts at the same time you're trying to learn calculus. And that kind of trips you up sometimes if you're not careful. Okay, so this is marginal profit. Now the second question asks us to use this same thing, except it asks us, what about if the units was 21,875? And you would be right. Because if you take that same profit equation, it's not Q anymore, it's 21,875. When you do the math, it comes out to be 0. So if we get a rate of change of profit at this many units is equal to 0, what does that mean?
Your profit's not increasing.
Yeah, it's not increasing, but it's not decreasing.
$1,875, that would be your break-even.
Exactly. I'm glad you said that because I was going to ask you that. So it's reached a maximum, and you're well, I don't know if I want to say if it's break even because that's when
I thought it
yeah,
would break even.
yeah, it would break even when cost is equal to revenue. So yeah, you could call it break even. So it's reached a maximum, and the company is at a break-even point. Yeah, you could still call it a break-even point. Because your profit's maxed out at that point, it's 0. If you continue to make it, you're going to start losing money. Up to that point, you were making more and more profit. Does that make sense?
Yeah.
Your income was still exceeding your cost steadily. But you've reached your maximum profit. That's the real big deal to take away from this, is you've reached maximum profit. You don't want to continue making more and selling more beyond that point.
Because beyond the point, you start losing.
Well, beyond that point, you're not necessarily losing money. What you're losing is profit. You're no longer making as much profit. Now, if you continue until your profit function, not the marginal profit function, but until your profit function goes to 0, After you pass the profit being zero, then you're losing money. Losing money is negative profit. Okay? Negative rate of change means you're still making money, but you're not making as much money as when you are making this many.
Is there like an inverse thing to that where like you would be losing money if you had put in like negative 21,875? See what I'm saying?
Yeah, but you can't make negative units. Does that make sense?
It's decreasing.
Yeah.
Or if
Remember
you,
this-
or if you like multiply that by 2 and then it'd be the same, like you go up to 21,000 and then back down.
Okay, let's explore that because we've got it in the calculator already, so we could plug that in. Actually, I don't think I want to use parentheses there. I want to use a times sign. I think that works. The calculator doesn't equate parentheses together and the actual multiplication symbol, but it kind of does the order of operations in a different manner. If it's parentheses, that's considered to be implied multiplication. But that's secondary to explicit multiplication, which is the multiplication sign. So I think that does it. I think that'll be okay. Because it should come back and tell us that it's negative 1.75, which tells you that your rate of profit is decreasing by $1.75 for each additional unit. Okay, that's what it's telling you. Now, if we go back and look at the actual equations for all of this, and that really, let me pull up my PowerPoint so that I can show you the previous slides, because you're asking good questions and this all makes good sense if you look at everything together, and I think this may be where it's coming together for you now. Okay.
So are you asking if like once you hit that maximum and you start, either if you start making less, if they'll still lose profit?
Like, I don't know, I see it like it's like a bell curve, like if you make enough and then you reach maximum and then you keep making more until you get all the way back to where you started.
Yeah, and that's what happens. That's why, this is your revenue equation, okay? This is not your profit equation. Although your profit equation looks similar to this. But this is your revenue equation, and basically, your revenue is increasing from the time you start with making no units to making more and more units. And your revenue continues to increase until you hit 25,000, looks like. But then after you pass 25,000 and you come down to 50,000, you're no longer taking in any sales. You're no longer making sales. You make 50,000 units, you're not selling them anymore. This also means your revenues slowly decrease because you're making more than you can sell. Okay? Which also means that your profit's decreasing because your revenue's decreasing. When your revenue starts to decrease, that makes one factor of your profit equation become negative. Okay? So if we graphed the marginal revenue, and this is just the revenue function, so if we graph the marginal revenue function, which I think I've already done, or the marginal profit function, not marginal revenue. Here's a graph of that function, okay? The one that we're looking at right here in this example, number 9. So when Q's 15,000, right here, the profit is about $15,150. But notice that your profit's still increasing at that point, because it's still traveling up. When you get to 25,000, your profit is about 16,650. But you've already passed the place where your profit maxed out. And your profit is now decreasing. You're still making money, but it's decreasing. Okay, because this is not your, this is your profit equation, so you made your maximum profit right here. You're still making profit, but you're making less and less and less profit as time goes on. Or
But
as you make
eventually,
more and
as
more
it
units.
starts going down, the more units they make, they will start.
They will start losing money, and even though it doesn't show it on this graph, where it's gonna start, where that profit equation is gonna go back to zero, which is the true break-even point, that's where, you know, you better quit here, because, you know, you did well here, you're always making profit as long as you don't cross over the x-axis, but once you hit your peak on profits, you're making less profit all the time. So if you keep pushing, eventually you're gonna hit the place where you have a true point of no return. You made too many, and now you're stuck with all this stock and you can't sell it. You're not selling anything. You got a warehouse full of stuff that nobody wants. Okay? And that maximum point, I'm sorry, I don't want to call it a maximum. That point of no return, let's call it. That point of no return is going to be when Q hits $50,000. Okay? Your rate of change is going to go negative at that point. But so is your profit. It's okay for your profit to stay positive and your rate of change is negative. You just probably want to slow down production. But if you hit that place where your profit and your rate of change are negative, you're in trouble. You might be looking at bankruptcy. Okay? So y'all are asking good questions, and this is where I want it to make sense to you.
And that would be where maybe when it was 25 cents.
Right. And then the third one says, what if you make 25,000 units? And that actually was on the graph that I just showed you, but just briefly here. All we're gonna do is change that 21,875 to 25,000. And notice now your profit is increasing or decreasing at $2.25 for each additional unit.
That's not right for that times 2 times, but it's actually negative. It has negative.
Let me check my notes. I think you might be right.
Yeah, it's negative.
That's why I hesitated about using the multiplication or if I should use the parentheses.
I just-
It should have been 2. It should have been 25 cents.
Yeah, it's fine.
25 cents.
Negative.
Let me try and see if the parentheses makes a difference.
It's only because you have times 2 times that, that's why it's like that.
Ah, yeah, you're right. That's what I need to delete. I forgot we put that in there for the other problem. So yes, it's negative 25 cents. So your profit is decreasing about 25 cents for every additional unit you make. Okay? And then the last thing was that graph that I'm showing you. That's actually the last of that chapter, is to look at that graph. And then the last part of example 9, which I don't think I made paper, I think I just wanted to do this. This graph shows you your marginal profit function. And this should make sense to you because think about what that function is. It's linear, right? That marginal profit function is linear. And it has a negative slope. So that means essentially from the time, let's see, from the price up here of the 175, from that fixed point, your profit is pretty much constantly decreasing from that point onward. So at P prime of 15,000, you see that you have a positive profit. But when Q is 25,000, you see that your profit down here is negative. P prime is negative. The value of the derivative is negative. The value of the rate of change is negative. Okay? Even though it's constantly going downhill here, still your values of your derivative, your slope of your profit formula are still positive. So you're still making profit. Once you cross that x-axis, there's where you're in trouble. Now, before we go on,